Good morning, good afternoon, everybody. First of all, I welcome all of you to join us at this webinar, which is on soil, which is one of the GLOBE protocol. And Rod and Joan, they made a presentation at the workshop, GLOBE Bhutan Teachers Training Workshop. And I wanted this to be shared with all the participants in our region, because that is a wonderful presentation. Also, I would like to remind all of you to look for the annual conference, Global Virtual Annual Conference, which is 25 to 29 in July. And I think registration is open or will open very soon. And those are the country coordinators or the teachers who want to join and need any help from our CEO regarding the registration, please let us know so that we try to find out some resources or subsidy for you to join the virtual conference. And working with also you can start registering yourself so that we can have quite a good number of participants from our region. In fact, our region is one of the very active region working, and also we would like to have some activities about our capacity building project. And already I have asked Joan to prepare up a video for us, and also I'm going to request other country coordinators or potential participants to do some to play active role in implementing capacity building project, because that is very important project for us in our region, and we want to take full advantage of this project and then implement it successfully. We know that we had very hard time, around more than 2 years, very hard time we had. But I hope this now we are in habit of this corona or whatever is there, and now we will be able to work very actively, and hopefully this webinar will be very useful and helpful. Not going much into the details because usually we have discussion after the webinar is over. I request Rod and Joan to make the presentation, and those of you who have any question, please enter into the chat box so that they can respond to your questions and the query. So to you, Rod and Joan.
So, don't touch the wall, okay?
Okay, just give me a second here.
Sure.
Okay, as you can see, the dates in the slide, it says 28th of April 2022. It's the same slides presented by the GLOBE Program Philippines to Bhutan on that date. So the teachers from Bhutan who has attended who has attended that seminar will be listening or will be seeing the same slides that were shown to them last time. So again, a very warm greeting and a very good afternoon to everyone. My name is Allen De Lara. I am the country coordinator for the GLOBE program in the Philippines, and with me is Ms. Joan Callope, the assistant country coordinator for the GLOBE program in the Philippines. So again, a warm greeting, and some of you may have heard of the Philippines. I'm not sure whether everyone has heard of the Philippines. So by way of introduction, I would like to introduce to you the Philippines, tell you where it is, who we are as a people, and some interesting facts about the Philippines. So the Philippines is affectionately called by the Filipinos as the Pearl of the Orient Seas. It is a name coined by our Spanish colonizers back in the 1750. And the Pearl of the Orient Seas aptly describes the beauty and splendor of this country. We are located in Southeast Asia and situated right above the equator line. And because of this, we enjoy tropical climate all year round. It's hot during dry season and rainy during the wet season. How rainy? On average, we are visited by 26 typhoons in a year, and that is in a span of about 4 months. So in essence, during summer, it's very hot and dry, and during rainy season, it is wet and rainy. We are an archipelago consisting of about 7,100 islands. However, I have read an article in the National Geographic that says that we have about 7,640 islands. That's probably because they counted the islands during low tide. So what I'm trying to say is the number of islands depends on whether you're counting them by during low tide or high tide. So with so many countries, with so many islands, we also have one of the longest coastlines in the world. If I'm not mistaken, we have the 5th longest coastline in the world, which means we are basically surrounded by seas. Regrettably and surprisingly, many Filipinos don't know how to swim. And that includes Joan Callope, who hails from a town that's surrounded by seas, and she never learned how to swim. Am I right, Miss Joanne? Basically, swimming isn't our strong suit in sporting events, rather boxing and basketball. Some interesting facts about the Philippines. We are home to the world's longest underground cave river that stretches 24 kilometers and was formed naturally millions of years ago. Despite our relatively small size, but a population of 100 million people, we have more than 175 dialects. Unfortunately, I can only speak 1 out of 175. Joanne could probably speak 3 out of 175 dialects spoken in the country. We have 3 of the top 10 largest shopping malls in the world. So short of saying that we are the shopping mall capital of the world. We even have an island that has more volcanoes than towns, and that's about it. That is the Philippines, and we hope that one day you could all come and visit the Philippines. So let's begin. Here is our presentation outline. Basically, the objective of our presentation is to learn the importance of soil. Why study soil? Why is it important? What are the different properties of soil? We will also be showing you references, very useful references that you can refer to for more details in the event that there's too much information shared to you today and that you are unable to absorb all of them. We will also be discussing to you the different soil protocols in the GLOBE program, namely soil temperature, pH level, soil moistures, and fertility tests. We will be skipping the frost tubes. As we discuss these protocols, we will be giving you a short lecture and then take you out in the field and show you how this is done. And that's going to be the coverage of our presentation today, which we estimate to take, which will take us about an hour or an hour and 15 minutes to complete. Why is soil important? Why research or study soil? So think about it for a few seconds. Why is this important? Well, quite literally, life on Earth as we know it cannot exist without soil. Soil is one of the most important natural resources that we humans depend on and cannot exist without. Soil provides anchorage for plants and trees to grow. Without soil, many of these trees, which we depend on for the production of oxygen that we breathe, cannot grow. Have you any idea how much oxygen a tree produces a year? 260 pounds of oxygen a year. Thus, it takes a total of about 80 to 100 trees to support the oxygen needs of one human being. The soil also provides much of our staple food. Thus, the quality of soil is essential and is in fact the backbone of every nation's food security agenda. Former US President Franklin Roosevelt sums up the importance of soil in human development when he once said, "A nation that destroys its soil destroys itself." Now that's a very beautiful, those are very beautiful words. A nation that destroys its soil destroys itself. Somehow when I recall this statement of President Roosevelt, it reminded me of what happened to the Philippines with reference to our rice production. You see, in the 1970s, the Philippines is one of the largest or top rice exporters in the world. But in the last 10 years, we have become from a rice exporting country to a rice importing country. We are in fact the second largest rice importer in the world, next only to China. Next only to China. So for a country like us who used to sell rice to the world, we have come to a point that we can no longer produce enough rice to sustain our own needs. Now, there are many factors that could have contributed to that problem. Population is one, the land area is one, so on and so forth. But one cannot discount the problem on soil quality. So again, this is why soil is important, and this is why we should sustain researches and studies on soil. This slide summarizes the functions and importance of soil. Soil delivers ecosystem services that enable life on Earth. Soil helps in purifying water and soil contaminant reduction. Now, it's very easy to relate how soil functions as a natural filter for drinking water. I don't know whether you've seen, whether you have in fact bought yourselves an organic, non-electricity based water purifier. If you know what I'm talking about, you've seen these devices where it cleanses and purifies water, and it has a layer of pebble, a layer of sand, a layer of charcoal, and some layers of soil. And as you put water on top, it naturally drains the water to a point that it becomes pure and good enough to drink. That's exactly those layers of materials, the pebbles, the charcoal, the granular soil. Those are the natural materials of soil. And that is exactly what soil is doing to us. Every time there's rainwater, and these water seeps into the ground and into our aquifers, water tables, and natural drain systems such as lakes, which we eventually use for drinking. So water is essential in providing us a steady supply of drinkable and clean water. Soil also acts as a natural climate regulation. And later on, we will see why there is a need to monitor soil temperature, because different types of soil have different abilities to reflect and absorb heat. I mean, you can't avoid discussions about climate regulation because of global warming. So somehow soil may be contributory, or the quality of our soil is contributory to these climate changes. Soil also acts as a natural nutrient recycling system. Soil helps to decompose organic and inorganic matter. So imagine, you see, soil contains a lot of these microorganisms, bacteria, fungi that helps in the recycling, in the decomposition and recycling of these decomposing matter. Soil provides habitat for organisms, those organisms that I have just said, which helps in the recycling of matter and nutrients on Earth. Soil, you may not know, significantly regulates flooding. And one of the GLOBE program protocol is in fact measuring the water retention of soil. We call this soil moisture protocol, because different types of soil have different capacity to retain or absorb water. So imagine if you live in a place where the soil has all been eroded. All these water trickling down from the mountain, either through natural precipitation or rain, will just go cascading, will just keep on cascading down the mountain and into towns. But if you have some sort of a buffer in those slopes, such as soil, then a good amount of those water can be prevented from cascading down in towns and producing floodwaters. So soil is also the source of medicine, a primary source of pharmaceuticals. In one study by the USDA, it was estimated that as much as 40% of modern medicine came from plants, 40%, including the top 20 drugs sold in the United States. That is how important soil is, as it provides foundation for these pharmaceutical plants for us to use as medicine. Soil provides foundation for human infrastructure, provides construction materials in the form of wood for making houses, building bridges, so on and so forth. Soil is the reason why we are able to maintain some of our culture. So it is a source of cultural heritage, especially for agricultural countries like the Philippines and of course, India and much of Asia and Southeast Asia. It provides us food, fiber, and fuel. And of course, as I have mentioned, it plays a very important role in carbon sequestration. We talk about climate change, global warming. The main culprit of global warming is excess carbon dioxide in the soil. And one way to reduce carbon cycle in the atmosphere, one way to reduce carbon cycle in the atmosphere is to plant more trees. And where do trees grow from? They grow from soil. So soil is very important, and humans cannot live without soil. But remember, not all soils are equal. There are many types of soil. There are clay, sandy, silty, peaty, chalky, loamy kinds of soil. Soil can also be characterized in different ways by how it looks, how it feels, the texture. It can be granular, it can be blocky, it can be platy, it can be columnar in form, etc. And different types of soil have different general characteristics, and they also have different properties. Properties in terms of their ability to deflect and absorb heat, their ability to retain or absorb water, as well as the type of nutrients and mineral it holds. Now, all this understanding about the properties and characteristics of soil is very important, especially when we study soil as part of the food security, for example, agriculture. And again, those are just some of the many reasons why we should research and study about soil. Talking about properties of soil, let me just discuss with you and give you a very short discussion about key properties of soil. Properties that are part of the GLOBE protocol. First is the soil temperature. Now, okay, the soil temperature at what you're seeing, is the average surface temperature of soil over time from January to December. The soil surface is very sensitive to air temperature, and it is very dependent on the time of the season, meaning there's a very close correlation between air temperature and soil temperature. But what is interesting is that as you go deeper, soil temperature, in this case, the green line is the soil temperature taken over a period of 1 year at 0.5 meter deep. You can see that it is varying according to season. However, the variation, it is less variable compared to temperatures at the surface level. In fact, as you go down deeper, you can see the same variability, but with a lot less variation. And as you go down even deeper, you will see that there is a tendency for soil temperature to sort of remain stable over time, regardless of the air temperature. Now, this is so because, again, the soil acts as a conductive, no, not conductive, but has insulating properties. It has this ability to insulate itself from heat. So again, this is a natural property of soil, that the deeper that you go, and measure the temperature, the more stable it becomes. Under normal circumstances, one would not expect any major changes in soil temperature over time, unless something happened either on the soil cover or on the soil quality itself. What I'm trying to say is, because of the inherent and natural properties of soil, these temperatures are expected to remain relatively stable and constant over a period of time. But however, should one find that there is significant differences in soil temperature, then it is a signal that something might have changed. What could have changed? The vegetative cover, the soil composition itself, the minerals in it, etc., etc. Whatever it is, any change in these expected temperature deviation would mean change in soil characteristics. Oops. So going back, why measure? Why study soil temperature? Very simple. Because different plants grow best at different temperatures. For example, let's take a look at this first row here, asparagus. Asparagus grow best when the soil temperature is at 95 degrees. Sorry, it is at 75 degrees Fahrenheit or 25 degrees Celsius. At that temperature, we expect 95% germination of asparagus in as short as 10 days. So if one can control temperature at that level during the germination stage, we expect about 95% survival of these asparagus seedlings. And we will see emergence in 10 days. For lima beans, another example, 90% germination within 7 days. But as you go to the extreme hot on one side, extreme coldness on one side, you will see that both and they have not done or heard, they have not done pH testing or heard about pH for that matter. But it is important for the next generation to understand the science behind farming and in this case, the science behind soil management. So what again is a pH level? A pH is a measure of how acidic or basic water is. So again, pH level measures the pH in water. And of course, water is also inherent in soil, unless of course the soil is bone dry. The pH is measured in terms of pH scale, 0 from one end, 14 on the other end, and 0 to 6 is basically acidic, and 8 to 14 are called bases or alkaline. Or the alkalinity of water is high if it has a pH of over 7 to 14. Just to give you an idea of what pH level is relative to common household items, hydrochloric acid has a pH of 0, On one end, pipe drain cleaners would have a pH of 14, which is pure base. A bleach soap, soap and bleach would have a pH of 11 and 12 respectively. If you love to drink coffee like I do, coffee has a pH of about 5 to 4.5. Wine has a pH of 4. Vinegar has a pH of 2.5 to 3, so on and so forth. Water, and I must say this and qualify this, water, pure water. By pure water, I mean deionized water has a pH of 7. So don't be surprised if you take a bottle of water and test it for pH. It might not be exactly 7. Why? Because bottled water is not necessarily pure water, and the minerals in that water may impact the pH level of that water. And this is also the reason why that when we do laboratory involving water, or lab works involving testing of pH, we would often use deionized water. But deionized water is not easy to come by. So for laboratory purposes, distilled water is good enough. Okay. So again, the relationship between pH levels and certain nutrients in the soil. The three most common and most popular minerals needed by plants to grow are nitrogen, phosphorus, and potassium. Later on, Ms. Joan will be demonstrating to you how to conduct an NPK test, which basically measures the presence of nitrogen, phosphorus, and potassium in the soil. But that's not the only nutrients plants need in order to grow. It also needs sulfur, calcium, magnesium, iron, manganese, boron, so on and so forth. You see, the presence of these nutrients, minerals, is also dependent on pH level, the pH level of soil. At a certain range, for example, pH of slightly acidic to slightly alkaline, nitrogen is most abundant. Phosphorus, more abundant in slightly acidic and slightly alkaline. Potassium, the same thing. But as the alkalinity increases, the pH level increases, potassium, the level of potassium in soil also increases. But it does not mean that more of potassium is good for plant. As you know, in the nature of things, anything in excess is bad. So as you increase the alkalinity of soil, you also increase the potassium content of soil, which basically is surpassing the average daily allowance for potassium, and anything in excess of that is no longer being utilized by plants. The same thing with phosphorus. But the thing with phosphorus is that as it goes in, as the soil becomes medium alkaline to strongly alkaline, the presence of these phosphorus decreases. So is nitrogen. The same thing with iron. At certain level, the presence of iron is more. At certain pH level, the presence of iron becomes less, and so on and so forth. So basically what I'm trying to say is that the sweet spot in terms of managing pH level of soil is between slightly acidic and slightly between 6.5 to 7.5, 6 to 7 pH level. And at that level, these nutrients and minerals are optimized, is at optimal level for plants that plants can use to grow. Just to give you an idea, certain plants grow best at slightly acidic soil, whereas some plants grow best at very alkaline conditions. So soil testing for purposes of determining the pH level of soil is important, especially in determining what plants grow best at what pH level. And in the event that you see that your soil, for example, is below the ideal level of pH for your plant to grow, you can manage pH level by introducing organic or synthetic fertilizers. But we'll go into that later on, and as we go on, how we can naturally manage pH levels organically. You would notice later on as we go into soil protocols that when we collect data about soil, we are collecting data at different depths. We collect data commonly at 5 cm depth and at 10 cm depth. If you want more, depending again on the objective of research, some would even go collect data on temperature, pH level, moisture at 10, 20, 30, 40, 50 cm depth. Why do we do that? Well, the answer is different plants have different, their roots go at different depths. And as these roots go down deep, the required nutrients for them to grow also differs. And that's the reason why certain plants, the roots of certain plants do not go as deep as others. And the answer to that is because of the nutrient that it needs to grow. So different plants require different nutrients in order to grow. And the nutrients in soil differs as you go deeper. As you can see, potato, for example, root crops, their roots are not so deep. Corn would have a deeper root system than potatoes. Tomatoes would have a deeper root system, as well as pumpkin. So that is why we study soil. And that is why in the GLOBE program, we collect data on temperature, pH, moisture, and collect data on different depths. It's for those purposes. So now in this slide, you can see references about the GLOBE program pedosphere protocol. I've also added a very good reference, which I always recommend to my teachers to have a look at it. And this is the NASA GLOBESMAP mission. If we will have time, I will explain to you what makes the GLOBESMAP mission very interesting. And you could easily get good student interaction, because what the GLOBESMAP mission is it allows you to track satellites, the NASA's SMAP satellite in space, and know exactly at what point in time and day that a certain satellite will be looking down at the site where you have collected data. You know, every time I show this to my teachers and students, they're always awed by it. So if you have time, go click that link. And of course, the GLOBE program pedosphere e-training, if you want to know more about the GLOBE protocol, pedosphere protocol, and would like to earn a certificate that you have attended such training, click that one. And with that, that's why we study soil, and that's why we have all these GLOBE protocols on soil. Shall I just continue and then take answers later on?
Yeah, you may continue.
Okay. We begin with soil temperature protocol. To me, this is the simplest of all the other protocols, because all you need basically is a soil thermometer. For this activity, you need a dial or a digital soil thermometer, a 12-centimeter nail or spike, a 500 ml beaker, a hammer, spacers. I will explain to you what the spacer is for in a short while. A calibration thermometer. Now, this is very important. In all the GLOBE protocols, it is essential that you calibrate your instruments first. Why do you need to calibrate? To make sure that your instrument is working just fine and that it is measuring what it is supposed to measure at a certain level of accuracy. You may also need a wrench for adjusting the thermometer, depending on the soil conditions. Sometimes the soil can be very tough that you cannot manually adjust them by hand, thus you need a wrench. You need a watch or a timer. And of course, we always recommend that you download yourself and print the soil temperature data sheet. You also need a ruler and some water. Okay. So now let's begin. As I have mentioned, the first thing you need to do is to calibrate your equipment. So in this case, to calibrate your soil thermometer. For this calibration exercise, you don't, any tap water will do. Any tap water will do. First step is you pour water into the beaker at room temperature. Then you place your calibration thermometer and your soil thermometer. Now, the calibration thermometer, at least how we do it in here, is that we get hold of a digital thermometer that we know is calibrated. Then you take your soil thermometer, which is normally a dial system, put them together in the liquid, and then wait for 2 minutes, and then read the temperature. If the thermometers, the two thermometers, if the difference between the two thermometer is less than 2 degrees, stop. Your soil thermometer is calibrated, and therefore you can use the digital thermometer for your data collection. If not, if the difference is more than plus minus 2 degrees, then wait for another minute and hopefully the deviation will be reduced to less than 2 degrees Celsius. If not, you can wait another 2 minutes, or it means that your thermometer is not as accurate as it should be. So again, always test and calibrate your equipment before collecting data. The next is to choose a site. You choose a site, download the GLOBE soil protocol data sheet, and fill in the site information. Now, this is important, especially if you are uploading data manually through the GLOBE website. You need the data sheet because when you upload them, you have to upload them in those data in certain sequences. And if you have the GLOBE data sheet, that makes it a lot easier because the data and information in the data sheet is consistent with what you would see in the website when you upload data. The next is to prepare the soil thermometer. In this exercise, we will be measuring soil temperature at 5 cm depth. First is you measure up to 7 cm from the tip of the soil thermometer and mark this spot, as you can see. Now, why 7 cm when we are trying to measure soil temperature at 7 cm? Because Normally, the tip of the soil thermometer is more or less 2 cm. And that explains why you are to measure 7 cm from the tip when you are measuring 5 cm. Now, with your spacer, mark the 7 cm spot. The spacer can be a rubber tube whose width is the same as the width of the soil thermometer, or in our case, we simply use a masking tape. Anything as long as it is strong enough to mark the, in this case, 7 cm mark. If you want to measure soil temperature at 5 cm depth, then you are to make the mark at 12 cm. Again, why 12 cm when you're measuring temperatures at 10 cm? Well, again, to allow for that 2 cm from the tip of the soil thermometer. The next is simply inserting the soil thermometer to the ground. Depending again on how hard the soil is, you may need a hammer for this. You simply prepare the hole for 5 cm depth, then it means you have to drill a hole at 7 cm. Place the soil thermometer, making use of that spacer or that mark, and that mark should be situated on top of the surface level. You do the same for the 10 cm mark. You prepare a hole that's about 12 cm in depth, and then insert your soil thermometer up to that mark in which you have marked with your spacer. When reading and recording soil temperature, wait for 2 minutes. Then record the temperature and the time in your science log. Then wait another minute. If the two readings are within 1 degree of each other, record this value in the data sheet. If the two temperatures are not within 1 cm, continue taking temperature readings at 1 minute interval until 2 consecutive readings are within ±1 degrees Celsius. For soil readings at 10 cm depth, you basically do the same thing. Okay, and when your readings again are within ±1 degrees Celsius of each other, then you can record that data in the data sheet. Now, I would like to show you a short video on how this is done in the field. So give me just a second, and kindly hold your questions. Okay. Oops. Okay, I have to wait a minute. Where is it? I think I should stop first, stop share. And then I should share again. Okay. Okay, so this will run only for 2 minutes.
Let us start with something simple, soil temperature protocol. For this activity, you need the following materials. 23 degrees Celsius, and 23 degrees Celsius.
And that's how you calibrate your soil thermometer. Now, I'm going to show you a video on how to take soil temperature data. So let me just stop share here and show you another video. Okay, sharing screen. Okay, just a minute. Okay, video playing. It's important that you do not pound on the soil thermometer or you might break it. That's the purpose of the 12 cm nail. As you can see, the spacer that we use in this thermometer is just a masking tape. There are instances when you need to make adjustments in the thermometer, and that's where the wedge comes in. But if the soil isn't that hard, you could probably move it by hand.
The time is 3:38 p.m. and the air temperature is 33 degrees Celsius. The soil temperature for 5 cm is 28 degrees Celsius. And for 10 cm, the soil temperature is 29 degrees Celsius.
So depending on the objective of your research or study, the 5 and 10 cm temperature reading may be done in the same point. Again, that will all depend on the purpose of your research. So with that, shall I continue, or do you want to, maybe I should continue and then take all the questions afterwards? We go now to soil pH protocol. I'll give you a very short lecture on how soil protocol is conducted, and then again show you a video on how to do it in the field. So with this, allow me to share my screen again. It's going to be a quick lecture. So you could always go back to the Globe website and download these presentation if it's too much for you to remember. So this is the soil pH protocol. For this activity, you need the following equipment. You need an oven-dried seed soil, distilled water, a pencil or pen, stirring rod, 100 ml beaker, a pH meter, a pH pen or a pH paper, and a balance with an accuracy to 0.1 gram. As always, and in all Globe protocols, we strongly advise you that you download a copy of the pH data sheet, especially when you are uploading these data manually through the Globe website. And you need a buffer solution for calibration. I cannot stress this enough that you need to calibrate your instruments first before you use them. There are different buffer solutions that you can use, and we will explain to you how to make use of these buffer solutions. They're not expensive, and a digital balance. By the way, on buffer solution, if you cannot get hold of these buffer solutions, but you should, and it's not very difficult to get them. Some, but we do not recommend them. Some makes use of certain liquids with known pH. Household liquids like a Coca-Cola has predetermined pH level, etc., etc. But we don't recommend that. We suggest that you do it right and you get yourself a buffer solution for greater accuracy. You need a spade as well. Okay, first things first, calibrating your instrument, your pH meter. For this, we use a 7 pH buffer. What it means is that this particular buffer solution has a pH of exactly 7.0. And we expect that our instrument will correctly read that level as we submerge the, in this case, the pH meter into that solution. So the first step is to pour your buffer solution into a beaker. Remove the cap of your pH meter if you are using a pH meter, and submerge the tip or the sensor of the device into the solution. Wait for a minute, then read the pH reading. Because we are using a buffer solution of pH 7, we expect the pH meter to read 7. And if If it gives you the correct reading, then you are okay. Your instrument is calibrated. Now, collecting a soil sample. First, again, select a site and fill in the information in the globe data sheet. Using a spade, collect soil samples. Place a cup underneath the sieve, then place some soil on the sieve and start filtering the soil by moving the sieve from side to side. And using an oven or a heating lamp, dry the soil at maximum temperature of 105 degrees Celsius. And in the lab, get a cup or a beaker, mix it with 40 grams of dried sieved soil with 40 ml of distilled water. Now, it's important to make use of distilled water and not just plain tap water. Why? Because if you are to use water coming from the tap, that water contains minerals and other elements that may affect the pH level of the soil. So to make sure that that the water will have no or very little impact on the pH level of the soil, use distilled water. Better yet, deionized water. Next is stir the soil water mixture with a spoon and other stir until it is thoroughly mixed. Stir the soil water mixture for 30 seconds and then wait for 3 minutes for a total of 5 stirring cycles. 5 stirring cycles. Then let the mixture to settle until you see a supernatant, the clearer liquid above the settled soil. Hopefully this will form in about 5 minutes. And then measure the pH of the supernatant using either a pH meter or a pH paper. And then record it in your data sheet. Repeat the same steps until all the samples have been measured of their pH levels. So let me share with you how to do this in the field very quickly. Allow me to share you a short video, how to do this in the field. Okay, just a second.
For this activity, you need the following materials. Let us now collect our soil sample.
just a point of advice, not all bottled water are distilled water. Some bottled water that you can buy in a convenience store, they are mineral water. They contain minerals in it, whereas some indicates distilled water. So they are different. For this protocol, we recommend distilled water.
The pH is 6.5. The pH of sample 2 is 6. The pH for sample 3 is 6.5.
And that's how you conduct a the globe program pH protocol. So finally, allow me to show you the soil moisture. The soil moisture is a bit more technical. So let me just share you my screen and then conduct a very short lecture on how this is done, and then show you a short video on how to do this in the field. Yep.
Sa gym daw tayo na.
Okay. Soil moisture protocols, as I mentioned, this is a bit technical compared to the two other protocols. For this activity, you need the following. Again, the soil moisture data sheet. We will be using the star pattern. There are two types of methodology recommended by Globe. For this exercise, we will be showing to you how the star pattern sampling technique is done. You need a compass, a trowel or spade. You need about 6 soil sample containers, sealable bags, weighed and labeled with their mass and container number, a meter stick, a ruler marked in millimeters, and science log pens and pencils. So let's continue. First, of course, is to select your site. You choose a site. Trace the 2 meter by 2 meter star pattern. As I said, it's a bit more technical than the two other protocol. This star pattern is available at the Globe website. So trace it. This star pattern has a diameter of 2 meters. And then identify 3 sampling points out of the 12 potential sampling points where each point is within 25 cm of each other. Again, depending on your research objectives, you may do more than this, but then if you want to do it at the minimal, then 3 sampling points from within the star pattern is sufficient enough. Collect 2 samples from each point, one at 5 cm and the other at 10 cm depth. Clear sampling points of any debris. Remove from the loose soil any rocks larger than a pea, large roots, worms, and other animals, if any. Dig a hole between 10 and 15 centimeter in diameter to 5 cm. Leave the loose soil in the hole, and then using a spade or trowel, fill your container with at least about 100 grams of loose soil. Immediately seal the container to hold the moisture. In the field, record the container mass and the number on the data sheet next to the sample. Remove all of the soil from the hole down to a depth of 8 cm. And in a clean container, collect a soil sample that contains the soil between 8 and 12 cm. Remember to remove any large debris. Record the container mass and number on the data sheet next to sample 1, and repeat the process until you have obtained soil samples from each of the 3 sampling points out of the 12 that you have selected. Now, after you have collected your sample, your soil samples, you go back to the lab, you calibrate your balance, weigh the wet soil samples one by one, and record the mass to the nearest 0.1 gram as wet mass. Then let these wet soil sample to dry beneath a 250-watt heating lamp or oven with maximum temperatures of about 105 degrees. Calibrate your balance. Now the next step is weighing the dry mass. First is to calibrate your balance, making sure that it is accurate. Weigh the wet sample, soil samples one by one, and record the mass to the nearest 0.1 gram. And then fill in your data sheet. Okay. Let me quickly show you how this is done in the field, especially how you trace the star pattern. Okay, just give me a second.
So can we take the picture?
Picture.
Just because some people are leaving now. If we take the picture, just 1 minute.
Sure.
Hina. Sonal, can you take the picture? Joan?
Yeah, we are doing it.
Okay. Everybody, please open your cameras. Please open your cameras. It's okay. Have you done?
Rod, I have to stop your share because otherwise we won't be able to see everybody. Just let me.
Okay, here you go.
Yes. Please open your cameras. It's okay now?
Yeah, it's okay. Rod, you can continue. Thank you.
Okay, so again, let me just quickly play this video. It's a short video on how to do the soil moisture protocol using what we call as the gravimetric procedure.
For this activity, you need the following tools. After selecting the site, the next step is to trace the star pattern.
You need the compass for proper alignment and symmetry. So she is preparing the point 1, which is pointing north. And then now with the compass, she's preparing point 5, which is facing south. Again, the compass is used for symmetry. She's going to the west side, point 7. And then at the end of the mirror stick, she is placing some pegs. And she's on the point 3, the east side. And now she's completing all points as it appears in the star pattern. You would notice that there will be 12 points in this star pattern, and you will notice these dots in between those numbers. Because the soil moisture protocol can be used in tandem with soil temperature protocol. So those dots in between those numbers, they represent potential sampling points for soil temperature protocol. So again, the soil moisture protocol can be used in tandem with the soil temperature protocol. And those dots that you see in between numbers, they represent sampling points where you can insert your soil thermometer. So what Joanne is now doing is that with the use of a rope, a string, she is connecting all those points so that they form this star pattern as recommended in the protocol. So again, each of those 12 points represents sampling points. Depending on the object of your research or the objective of your research, you can collect samples in each of those 12 data points, or you can randomly select any 3 points, provided that each sampling point is within 25 cm of each other. So what Joanne now is doing is she's simply placing those points along the star pattern just for reference. Now some of you might be wondering, why so many data points? Why can't you just measure moisture at one point? Well, so that's the star pattern. So you can randomly select any 3 sampling points, making sure that each sampling point is within 25 cm of each object. For this exercise, we selected points 2, 3, and 10. Again, as I was saying earlier, some of you may be wondering why so many sampling points. Why can't you just measure soil moisture at one point? Well, the answer to that is if you are to take one sample, or if you are only to take a sample from one point, then there may be local conditions in that particular point that may not be present in the other points, and therefore the reading may be significantly different, not because simply because there are conditions in that particular sampling point that may not be present in the other. What particular condition? I don't know, maybe a dog, for example, would feed at a certain point. Oh, also, I need 5 more minutes here. 5 minutes pa. Okay, so 6 samples were collected, 1 from each data point at the depth of 5 and 10 cm. Now it's time to measure or weigh in the samples. Don't forget to measure the weight of your empty container, record the mass, and label them as wet mass. And go back to your data sheet and then fill in the details. After this, we go back to the lab to dry the wet mass. Set the temperature to about 105 degrees Celsius and try not to exceed 110 because at that point soil structure begins to break down. And when it is all dried, it's gonna look something like this. And then you start measuring them, weighing them. And this is now the dry weight as opposed to the wet mass. And then fill in the data, and you have completed your soil moisture protocol. And that's about it. Now, if we still have time, Joanne can show you how an NPK test is conducted. If not, then what's the pleasure, Desh?
We will have another round of webinar because it's already more than how much? Wonderful.
Right.
It's more than 1 hour, 35 minutes. It's wonderful. Rohit and Joan, both of you have done wonderful. You are great trainer. In fact, when you made presentation at the e-training in Bhutan, I thought it will be very useful for us if we can have it for wider audience. And you will be happy to know today we have 98 participants, uh, like 43 students from Nepal, 10 from Bhutan, some teachers from Bhutan, first time country coordinator and teachers. And also we have more than 10 countries represented at this webinar. This is a great number and very increasing. As you know, we are implementing capacity building project. This webinar is sort of part of our capacity building project. And I can see Rod and Joan, you have done wonderful photography. And also, I hope the video which you are preparing on data will be out soon and we can share with others. Now, we will be having our another webinar sometimes in June. In the month of June, we will be having 2 webinars. And please volunteer who want to volunteer yourself as one of the speaker at the webinar. If anyone you have any questions, please ask, or you can put in the chat box. And then there have been very interesting questions by the students from Bhutan and Nepal. I think Bill also replied some of them, and I hope that is great. And now, who would like to have a next webinar and when? Please let us know so that we can plan accordingly. And we are happy that many of our countries now, we are getting to the normal situations. The schools are open and some activities are going on. In fact, another request I want to make. In fact, we thought that we can have our regional meeting in Maldives. But when I calculated the cost of the tickets from Marshall Island to Maldives and then Pulau, Micronesia, because I want all countries to come. Though that is so expensive, the distances. So we have to have meetings somewhere in a central place where everyone can come and we can have this meeting within our limited budget. So please, I think Philippines, if the situation is good, road next sometimes in April, we would like to go back to our original plan to Philippines, and also we would like to visit Bicol, the project of the tree plantation which you are doing there. If possible, please consider, and my first choice will be Philippines. The second choice I will request Professor Paliam to host in Taiwan. I think we would like to have this regional meeting at a central place where everybody can come. And under our capacity building project, maybe I will request we can have one part of the meeting in Philippines, so someplace, I don't, sorry, in New Zealand, sorry, one part of the meeting in New Zealand. We have wonderful trainers, and then within our region, and then look into maybe Thailand again, we will request. So this year and the next year, we want to be very hectic, very busy, lot of things to happen. In fact, Changa was very kind, inviting all of us to Bhutan when it opens. Maybe we can plan some expedition to Bhutan or something like that. Changa, we welcome you are here. Okay.
Yes, Desh, I'm still here.
Yeah, you are here. Okay.
Yeah, I think like
I'm very happy.
we'll be very happy to welcome you here once everything gets settled. As of now, I think like the situation is improving. So we hope that we'll be able to host you here. Thank you, Desh.
Thank you, Changa. And so that this year, the rest of the months, and then next year, we want to make it very hectic, and then number of activities which we could not do for the last 2 years. We want to do this now, and then please, we would like the cooperation and help from each one of you. And also, for those who are interested joining the teachers, the country coordinators joining annual conference virtually this year, and certainly face-to-face next year in Boulder in July 23. And please feel free if you want to join, so that we can try to find out some registration money for participants from our side to attend the meeting. And if anyone want to make any comment, any suggestion, please feel free before we close down the meeting. Anybody who wants to make any comment? Any comment or any suggestion?
Joanne, would you
Okay.
like to add anything? You raised hand a little while ago.
Just to wrap up the presentation of Rod, in collecting the soil data, you need to select the appropriate site, which is of course dependent on the kind of the research that you will be doing. Also, there are some important things that you need to take note, like for example, the name of the site, also the coordinates, the latitude, the longitude, which is also automatic if you use the Globe Observer app. If not, you can use the Google Map or the compass from your phone. You also need to take note of the elevation. Also, you need to take note of the date and time when you collected the data and the kind of the instrument that you use. You are also required to collect data at least 3 times for its sample, which will be determined by the researcher. And then you need to observe some precautionary measures like wearing proper attire for field or for laboratory experiment. You need to use gloves, face mask, and goggles. Also, you should know how to dispose the chemicals and the samples that you use in studying the soil. So there are also things that you need to bring in the field or in the lab, like the copy of your protocol, the data sheets, the materials for calibrating your instrument, and the materials listed in the protocol for collecting data. After collecting your data, so Rod presented how you collect the data, the video of collecting the data. You must not forget to enter the data in the data entry of the Globe website, or you can use the Globe Observer app. But currently, the pedosphere is still a work in progress in the Globe Observer app. So for now, you can use your data entry from globe.gov. And when you want to see this data that you uploaded in the website, you are just going to click data visualization. And if you are going to use this data for your research, you need to click the RDAT, okay, or retrieve data. It may come in the form of Excel or CSV. That's all because our time is not enough.
Okay. Okay, thank you, Joan. Wonderfully done. And thanks for any more comment or any more suggestion from Thailand, from Australia, from any Bhutan, okay, already Nepal.
Dish,
Yeah.
as such, I don't have any comment, but I think, John, we would like to thank John and Rod for these wonderful sessions. Of course, we had the pleasure to have the training session during the Globe meeting, but during that time, there was some internet interruption. So because of that, we couldn't get most of the things that they are saying. But today, we had another opportunity to attend their session. So it makes a lot of things clear to us. And I hope that today we have around 10 teachers who have attended these sessions. And I hope that they have more information now to carry on their activities in their schools. So once more, on behalf of teachers And on behalf of all of us over here, we'd like to thank John and Rod. Thank you very much.
Thanks, Changa. And I just want to mention that this presentation will be on the YouTube. We will send you the link, and then the students can make always use of this. I'm happy that some students also joined. That is great. Thank you very much, Changa, and also number of students from Nepal, India, and that is great. So you want to say anything, ABC?
Yeah, Dr. Desh,
Yeah.
thank you very much for us, right? It's a great opportunity for us. We have been doing wonderful job on mosquito. We have just been awarded with the Young Scientist Award from USA, Colorado one. So it all goes to you people who are doing wonderful job behind, right? And the students are participating. They are inspired to do something different. So today's webinar was somehow attended by 43 students from our school. So it
Very
was
good.
amazing thing. The inspiration you could feel, right? It was amazing for the students. They were very inspired, and they want to participate in some of the physical, what do you call, face-to-face programs. If it would be possible, then they could personally meet you, and that would be inspiring for the students. Just before in Pokhara, this Dr. Desh was being attended by some of our students. They still have the talk about you. So it is quite inspiring for everyone to be such an inspirer, such a motivator for the young generation to come forward with the science. And it's hopefully a best program for the students because they do learn and again present. So with the huge motivation, they are working out. And I'm very thankful to whole team of Globe, Eka Nepal, Yogendra, Chitrakar, and everyone who really attended us, approached us to you all. So I'm very thankful.
Thank you very much for such a large number of students joining from Nepal. I think that is great. And sure, whenever you have any program, please let us know so that some of those they can travel and join you face to face in Nepal. I think the travel in Nepal is now open. And if you have any activity, please let us know. Okay. Damayanti, you want to say anything? Damayanti from Sri Lanka. I saw you, Damayanti. Okay. Are you okay?
Which Damayanti, your speaker is muted. Please unmute.
Okay.
Sorry.
So something from Thailand? Okay, Damayanti, yes.
Okay. Yeah. Yes. Thank you very much for the nice presentation, John and Rod. And I think it's very clear with the practicals that all the protocols, and I think we can also use it when doing teacher training and all. Thank you very much again.
Okay. Thank you, Damayanti. I hope situation will improve in Sri Lanka very soon. And
Hope so. Yes, hope so, Dr. Desh. And we are also with some difficulties with petrol and gasoline also. Yes. So, however, we can manage, but you know that the poor people here in Sri Lanka is with some living with some difficulties. But I think in the near future, all the things will be improved.
okay. Thank you, Damayanti. Bill, you want to say anything?
No, just to thank Rod and Joanne for the very hard work that they put into that presentation. It was very interesting.
Very interesting, very useful for those friends. Yes. Okay. From Bhutan, sorry, from Thailand. Thailand. You are here. You can speak in Thai. We will translate. Thai, she's very shy.
Hello.
Yeah.
Yeah. Can you hear me? Yes. I don't know. Pam not here. Yeah. I just want to thank you for Go Philippines, Rod and Joanne for the very good presentation
Why
and
you show your half
excellent
face?
video. Yeah, for their hard work to do that. Yeah, thank you very much. And thank you, you too. Thank you.
Thank you. Okay. Anyone, any more comment and suggestions, please? Anyone from Taiwan? Tina, you want to say anything? Tina is here. Tina. Victoria, you are here or still you left? Victoria left. Yeah. Victoria?
Yes,
are
I'm
here?
here. I'm in a car.
Okay, yeah, please.
Thank
Go
you.
on, Nika.
So I
Oh,
won't
it's
really say
nice.
anything except amazing work from Joanne and Rod with those presentations. Very clear in Joanne's description afterwards. So thank you for all your hard work. And sorry, I'm in a car again. It's always a car time for me.
Thank you. You are going to pick up B from this for yeah. Okay, great. Say hi to hello.
I will. I will.
Tina. Tina. Or Gary, Tina or Gary, anyone? Okay. Okay. If there is nobody, then okay then. Thank you very much, everyone. Wonderfully done. Rod and Joanne, always you are resource to the reason. And also both of them, they are the member of the working group. That is great. And then always we count on their support. And also, hopefully, Joanne is going to produce our video very soon. Thank you very much. And then now we can conclude our webinar for today, which is almost around 2 hours. Thank you very much for joining us. And I'm glad that more than 10 countries joined today and 98 participants, which is quite a good number. And I'm happy that quite a number of them, they are the students from they joined because this webinar will be helpful to them. Thank you very much. Have a nice weekend and let us keep in touch. And those of you are interested in joining the virtual annual conference, please let us know so that we can work out how we can arrange for the registration. Thank you very much. So we can conclude and stop the webinar.